There we go.
There
Okay. I've never been prime minister, so I guess I'm looking forward to this. I just have to get in gear with Dan about Zooms and that sort of stuff, but I'm sure it'll all work out. And I'm looking forward to the new season. Both, I guess we're still thrashing it out, but it looks like we may have a meeting over the summer, perhaps, to make sure that we kind of nail down the new procedure that we're going to go through with, some in person and maybe Zoom, part of it, so that we, meet everybody's sort of expectations here, and hopefully more people will be vaccinated by then and so on. And, Margaret's going ahead and doing her thing with the county Parks and Rec, and, we'll have the clubhouse, for that, which is, it's a new chapter, and I'm excited by it. So looking forward to taking on the duties, and I'll work my way through it as we go along.
It'd be great.
Be good.
How long has he been?
All right, cool. More people. Yeah. So it's been great to be your prime minister for the last 4 years, and I'd like to think those weren't an easy 4 years, actually, considering we've faced some things that we've never seen before in this club. So.
Yeah.
Appreciate you all, and look forward to continuing, and maybe one day again. So Phil.
Yeah. Okay. Well, since this is the last meeting of this season, I'm not going to announce any new speakers, but certainly is a pleasure to introduce tonight's speaker. Normally we see Tom in the middle of winter, when it's a great time to be in California, not so warm as in, or not so cold as in Wisconsin. So always a pleasure to hear Tom talk, always a pleasure to hear him on the side. So please, let's welcome Professor Tom Volk from University of Wisconsin-La Crosse.
Okay, how y'all doing?
Great.
Hi, Tom.
I'm glad to be here. We got up to 70 degrees today, so we're really excited.
Warmer than here.
Yeah.
We did have a couple of days of 80s in April, but it's been kind of cool so far, and we still have morels, so you can see you're still good size, and it gets really big. You can see the spores now. So thanks for having me. I got to share my screen and do this right. So I didn't know any about this because, before we had the pandemic, and now it's kind of the best thing ever. So I would rather be there in person, but this is almost as well. It's not almost as good. It's good. And so I'm going to talk to you today about everyday and extraordinary fungal superheroes. And so I want to see how fungi play a role in our everyday lives, and how they play a role in more extraordinary ways that may not be associated with every day, but might benefit us every day. So you've seen my La Crosse before. So this is taken from a 600-foot bluff overlooking the city. We're on the Mississippi River. So this is the river over here. So we're about a mile and a half from the river. And we have about 10,500 students at La Crosse, and we have about 1,200 of those are biology and microbiology majors. So we have a really good chunk of the school. It's a really good size. For me, we have, it's big enough that we can offer a lot of different kinds of courses, and it's small enough that the students get a lot of individual attention. So I like it. I teach courses in general mycology in the fall. So we cover all of the phyla and everything else. We do a lot of collecting. That's our season in the fall. And so In the spring, in winter and spring, I teach medical mycology. So these are fungi that infect people, like yeast infections and ringworm. And then there's other ones you probably have heard of in California, like valley fever, that are inhaled into the lungs and can cause pretty bad disease. I teach plant microbe interactions, how plants interact with fungi and bacteria and nematodes and viruses and what have you. Advanced mycology, which we now call 21st century mycology, which is basically we read a lot of different papers and we discuss them. Food and industrial mycology, I've taught at one point, but the professor I used to teach with left. So rude. Plant biology and organismal biology for I'm 2 degrees in botany, so that helps that. And I also teach Latin and Greek for scientists, which is really fun, surprisingly. And so if you come to La Crosse, I will take you to see the world's largest 6-pack. These are in fact filled with beer. And there's a little spigot here where you can get the free beer. No, that's not true. Okay, so I'm not sure when the last time I was in Santa Cruz was, but I couldn't come for a couple of years because I had an old friend who retired to Florida and he was very ill. And so I had to take that time to go see him for a few years. And then of course, pandemic happened. And so someday I'll get back there and it'll be fun. So I do love coming there in January. Okay, so I'm going to talk about the everyday fungal superheroes here, and you can see Mushroom Man is up here to support us. Okay, so most importantly, we think about, since a lot of people are interested in eating fungi, mushrooms make very good food, and so they're delicious and nutritious, of course. They have a pretty good protein file and pretty high in protein. That has a better profile than beans. It has all of the amino acids in them. I see Justin taking a selfie. It's funny. And of course, you shouldn't be too surprised about where they live. They have a lot of minerals in them and loaded with B vitamins as well. And so here's some nutrition facts for her. This is for the white button mushroom, but the others are similar. And so low in fat, low in carbohydrates, and reasonably high in protein for a small serving, 5 mushrooms. Okay, so if you compare that to beans that I've taken here, these are organic white beans. In part of you are blocking the screen, so you can see that there's 6 grams of protein here in a third of a can. Pretty high carbohydrates, fiber. It's about twice that of the mushrooms, but what you don't see in here is the actual amino acid profile in here. Beans are missing one of the essential amino acids. And then you get similar numbers with the other kinds of mushrooms. We all know that the white buttons and the crimini and the portobello are all the same species. And in fact, crimini and portobello are actually the same strain of the same species. But in any case, there seems to be, for some reason, some difference in those two. And when you look at these numbers in here, and you don't need to read all those profiles in there, but these are low calorie until you put the butter on. And so if you can cook them without butter, then all power to you. But for me, some mushrooms are just a vehicle for the butter. Okay, normally are you all capable of unmuting? Or is everybody set to mute?
No, we can unmute.
Okay, so let's name what we have here. So upper left.
Morel.
What species?
Escalante?
It's the same as this one,
Is
but
Morchella?
I don't know what it is, and I don't really care. I do know that these two are the same species because they were under the same tree at the same time. Well, actually, one of these, this one was in the sun and this one was in the shade. So they're so variable that I think it's near impossible to tell them apart morphologically. Okay, how about this? Puffball, there's a quarter there, so it's a good one. I once found a fairy ring of 53 giant puffballs, all in the edible stage.
Both
So
are
that was-
down here.
That was a lot of food. Actually, I sold them to restaurants because I had just graduated and didn't have a job. This one,
Oh, Belita sedulus. Or
you're close.
That looks like
Carrot?
Willis.
No.
No.
It's a Boletus.
Boletus.
I'll tell you it's from Colorado. Does that change your mind?
Oh, is
No,
that
it's
the-
still Edulis. They call it erythro something, but
Recolor?
it's still Edulis.
Are we back to Edulus again?
Yeah, it is. It's in that. Yeah.
So Rubriceps is gone.
Yeah. Yes.
Okay, that's too bad. It was a good pun.
Yeah.
Okay, this one.
Latiparus?
Which one?
I think that one's sold
Cementarius.
back there, right? Or is that,
That's what we're calling it.
okay.
I have advanced news that Ladyporus sulphureus in North America probably isn't the same thing they have in Europe.
Oh,
And so this probably needs a new name, like everything else.
Yes.
I don't know. This one?
Which one?
Kentucky.
Let's see.
Matsutake. Yep, there's the perfect button right there. These are actually from Michigan.
Oh, it's a different species. No, we have here.
Down here.
Andrew L.
Which one?
where are you?
Down the
East
right.
Coast.
So this is one of our new species from Wisconsin. This is Cantharellus phasmatus, the ghost chanterelle, because it's really white underneath. These are really fragrant. This one,
Meteorellis.
Cantharellus. I don't know which species it is. You're on your own.
Blood trumpet.
Where's it from?
This one,
Where are we? Oh, there.
Sulfur top.
Looks like a gymnopolis.
Yeah.
Sulfur something or other.
so this is like identifying pictures on the internet because I didn't show you the gills underneath and the annulus. So this is actually armory melia.
Oh,
Oh,
yuck.
Really
honey
yellow.
mushroom.
Yeah, your California ones are not this yellow.
No.
This one,
I'm having the
Okay.
experience of showing up for college, not having prepared for my homework.
Shiitake.
is shiitake. It's a cultivated one.
Yeah.
And this one,
Lobster.
Lobster.
and this one,
Crayfish.
crayfish, large crayfish.
Very
This is
low.
actually, for 3 times I've given a polypore workshop in Maine. And we have lobster there when, usually the last day, and we had lobster mushrooms with them one day. So that was fun. Ross, have you been to that?
No. Nope.
Okay. And here's my dear friend, Patrice Benson, who's since passed on, but she's here with her walkie-talkie matsutake. There are some other edible mushrooms. This is the International Medicinal Mushroom Society but a meeting in Slovenia. And so we went and we had this dinner at this country inn. There's me here, my student. And so we had truffles. So black truffles and white truffles. So the black truffles were selling for about 300 euros a kilogram. And the white truffles were selling for about 3,000 euros a kilogram. So that roughly translates to dollars per pound. And this is a really old-fashioned truffle grater. So it's like a mandolin, very fine slices that it makes so that you can put that on the food. And so at this country inn, this was kind of an odd thing because of a country inn, you had to make reservations so that they would actually open it for you because they don't normally just take customers. They walk in. And so very, very old building, and the man who owned it had dogs, and he hunted all these truffles. So he got them for free, except for the dog upkeep.
Wow.
And so we had a 4-course dinner. This is our salad with black truffles on it. This is Amanita caesarea, the real thing. And this is a prosciutto that the innkeeper had made himself. Second course was a soup. It was a cream of celery soup, and I grate the few slices of the truffle on top of it, and then you take a picture and then you stir it in. Because the truffle flavor, of course, is very volatile. The third course was this tagliatelle pasta, homemade, with white truffle on it. And so the truffles are absorbed, the flavor is absorbed into the fat. So you have to eat it with something fatty. And then you eat that, stir that in and enjoy it. And then even dessert was truffles. And so there was flan with truffle grated on it, fresh fig. And this was a poppy seed tort. And then a cream. This is a strudel with a cream that had truffles embedded in it.
Yum, yum, yum.
And so, and the farmer, the innkeeper made his own wine as well. So how much does this?
Wine?
I don't know. I have a picture. I didn't take a picture of the wine. Sorry. But it was stuff he made himself. So it was mostly, I'm not going to make up names because you all know, you're all from California, so I can't make up names. But it was one of those sweet wines.
Yeah.
It was a white. I don't remember the name of it.
So
how much does this cost?
$1 million.
So close.
It's living.
This is 25 euros, which is really cheap. That's like $35 or $40.
Yeah, right.
So, and it was probably because the innkeeper was friends with some of the people who were running the festival. And so we got a good deal. So that was my best truffle dinner. Okay. The other important thing about mushrooms is that they're fun to hunt and you can make a lot of new friends. And so I wouldn't know any of you without there being mushroom forays and such. And so I'll show you a couple of those. This is a foray in Quebec. This is the name of foray in Quebec. With the sorting tables here and then the display tables over here. This is in California. This is in Alaska. This is a workshop I gave in Rutgers, New Jersey. There's Bill Sabula at a foray in Florida. Some of you might recognize Orson Miller at a foray in North Carolina. So here's this whole room is actually the sorting room, and the display room is in another place. And this is a Mycological Society of America foray in Hawaii. So we went looking for stuff on the lava. There wasn't much there, but it was an excuse to go on the lava. And this was at Telluride. So you can see some people showing what russulas do when you kill them. I tell my students if there's fewer than 100 pieces, it's not a russula. And of course, who wears this? I mean, you might recognize where that is. So I love the display. This is certainly one of the best mushroom forays in the country. I've been to a lot of them. And this is right near the top. And so that will bring back fond memories and hope for the future when you can do this in person again. Okay, so there are some other everyday things that fungi are important for. You can make drugs from them, other medications. And so the first antibiotic was penicillin. And so this is actually a descendant of Fleming's original strain. And the yellow exudate you see here is penicillin being exuded from Penicillium chrysogenum. And so I've taken this and I've spread a lawn of bacteria on the plate. And then I added the culture of penicillium on here. And you can see the amount of killing that it does to the bacteria. Okay? And so these bacteria are susceptible to penicillin, but there's a lot of penicillin resistance out there. So, and there's what it looks like microscopically. So penicillus is a paintbrush, and that's where it gets its name. And so here's cephalosporin, actually this is called acromonium now. And so this is where we get the cephalosporin drugs. So there's about 1,600 antibiotics that are commercially available that are produced at least in part by fungi. So a lot of them have chemicals taken from them and the chemicals are modified. So compare this to plants, and there's only one commercially available there's only one commercially available antimicrobial compound that's made from plants. So who knows what it is? Think tropics.
Malaria drug?
Yep, think about gin and tonic, quinine.
Oh, quinine, okay.
I know, yeah.
Okay, so as I mentioned, we have some problems with drug resistance because of overuse of antibiotics and people not taking their entire course of antibiotics. And so there are lots of fungi that are resistant to, and bacteria that are resistant to antibiotics and antifungal drugs. And so we have things like MRSA, methicillin-resistant Staphylococcus aureus, VREs, and more. There is a newly emerging yeast infection called Candida auris, AURIS, that is resistant to all known antibiotics except a couple, naturally resistant. And so, and this also, Candida auris also stays on surfaces for a long time. So it can be easily spread in hospital settings and things like that. So if someone has Candida auris in the hospital, the room has to be totally disinfected when they are checked out. So a couple of my students have worked on antifungal drugs and antibacterial drugs as well, but I'm going to show you drugs from fungi. And so there's Nick, who works for CDC now, and my other student who has his own company making black garlic, fermented black garlic. Okay, so we want to take mushrooms and look for extract molecules from them and eventually make medicine that leads to cures for this, like this thing. So this is a fungal infection of the eye called keratitis. So it just grows on the lens, not on the lens, but on the cornea of the eye, which is keratin. And there's no antibiotics, antibodies or anything going to it. And so your cornea is a petri dish waiting to be infected. Okay, so Nick worked on this Hernia criterion, the black tulip fungus. That's this one, not this one. And we found a chemical from there using a disc diffusion assay. And so we spread the plate with bacteria and then added these discs that were inoculated with the compounds that we were interested in. And some of them showed this. So showed that there was a death of the of the bacteria around the edges of that. And so here's another one, and we can measure that and then isolate that compound and see what it does. And so the particular one that Nick isolated from Hernia is effective against Burkholderia, which is a common bacterial disease in people who have CFC. Okay. Can also do this other thing called an MIC, minimum inhibitory concentration. And so these are decreasing amounts of the bacteria put in there. The same amount of bacteria is put in each one. And then a certain amount of what we want to be antibacterial is put in there. And you could see in this well, these 4 are dead. And so this has a pretty low MIC. So lower number is better. So if you can use less of the chemical to kill the fungus, that's better. Okay? And so from that, we could then isolate the compound, and we have a paper that shows it's some weird thing that I'm not going to tell you about. Okay? So there are a bunch of other drugs that are anti-cholesterol, for example, lovastatin and compactin, which are sterile drugs, are produced by a couple of different kinds of fungus. This is Aspergillus terreus, it's probably actually Aspergillus malleus. And this is a trichoderma. So the birth control pill contains steroids, and the steroids come from a large vat incubation of Rhizopus nigricans. And so that's Rhizopus nigricans over here. It's one of the pin molds. I'll show you some of those later. And cortisone and prednisolone are also made from the same fungus. Okay, cyclosporine, the anti-transplant rejection, comes from the fungus Tilipocladium inflatum, now called Tilipocladium subsessilis. And this is a grub down here and the fungus growing from it. And this was what it looks like microscopically. Okay, and so you probably know that I have had a heart transplant. And here's me with my heart in a bag. This is actually, let's see, Saturday will be the 15th anniversary of my heart transplant.
Wow.
So that's hard to believe that it's 15 years since that all happened. So I consider those extra bonus years, and I'm really grateful to my heart donor and their family. I don't know who they are, but I'm grateful to them every day for my heart. Anyway, the fungus that comes from that is keeping me from rejecting my heart. So there you go. There are other kinds of fungi that produce drugs, some good, some bad. These are ergot alkaloids that come from this Claviceps purpurea. And this is a parasite on rye and other grains. This is actually the fungus here that's forming a sclerotium, a resting structure, and replacing the grains. And it produces a lot of what we call these secondary metabolites. One of them is used to facilitate delivery of babies. Another alkaloid is used to relieve migraine headaches. And it's a really strange drug. I've had students who've taken it and they have to take the drug and go sit in the dark for a while because it's inactivated by the light, even when it's coursing through their blood vessels. And the other interesting alkaloid in here is ergotamine, which in the body is metabolized to LSD. So this is really the natural source for LSD. And so there are lots of side effects of it. One of them is vasoconstriction, where the veins and arteries become constricted, and it can cause gangrene, limbs falling off, and things like that. And one of the ways to cure this was to make a pilgrimage to St. Anthony, And it always worked because that meant they left leaving their town and they're getting away from the source of the drugs. And so there's lots of really interesting stories about that. There's a book called The Day of St. Anthony's Fire, which is what this came to be known as. May have had something to do with the Salem witch trials as well. There was a paper published some years ago that concluded from looking at dendrochronology, so looking at the size of the rings in the trees around Salem, that these were wet summers, which was conducive to the fungus growing. And there were other things they looked at. The symptoms were really similar that the people were having who were accused of being witches. They were hallucinating, and some other people were accused of being witches because they were the people hallucinating that they had been turned into a toad or something, and the people in the room with them were obviously witches. And so, eventually people were taking advantage of this, like the Reverend Cotton Mather accused all of the women owning the farms around him of being witches so that he could take over their land. But probably the initial hysteria was caused by these fungi. So no, they'll probably never be able to prove it, but it's really interesting. Okay, so we have medicinal fungi that produce drugs that we use, and then some mushrooms are used directly as medicine. So almost always making some kind of tea or just eating them works as well for some of them. And so this is Reishi or Lingxie, Ganoderma lucidum. There's maybe some effects from other Ganodermas, seems to be in there as well. These are some we cultured. I'm waiting for the double-blind studies for this, but I think there's probably something to it. This is Grifola frondosa, hen of the woods, or maitake, or sheep's head. I know you don't have this in California. And so this is a particularly large one. This one was about 20 pounds, the largest I've ever collected. I've collected 2 different 26-pound ones. And so they can get to be very big, and the whole thing is totally edible. It's really good. So who's had that? People from the East certainly have had it. And there's some cultivated forms in California as well that you can purchase at the store. And they're pretty good. So there's some of these have chemicals in them that seem to enhance the immune system. But again, I'm waiting for the double-blind studies. But it's getting a little more credibility every year, I think. And of course, shiitake itself is reported to have lots of different effects, beneficial effects on a person. These are really weird, but this was some of the prototypes for marketing for the American Mushroom Institute. And so they were different mushrooms that were supposed to help different parts of your body. And so I'll leave it to your imagination to know what parts are helped by which mushrooms here. But they're really goofy. And none of them made it to final.
Actually, Tom, some of these I have seen published in some paperwork that was distributed at Far West one time.
Oh, okay, that's cool.
I happen to know that the one in the lower far right corner is known as shiitake. It's a little gendered and kind of not creative. And then the one above that is like boss something. I don't know. It's somewhere, but yeah, they did actually print some stuff with them.
Yeah.
I would interrupt.
Cool. Okay. There are also ways that we can exploit fungal life cycles to make stuff that we're interested in. So we call this food and industrial mycology. So we use mushrooms or mycelium usually to make different kinds of things. So one of them is in fermentation. So it's probably the most important fungus of all time, Saccharomyces cerevisiae. and the name translates as the sugar fungus of the beer. And so this is used to make, I'll show you the chemistry in a minute. So here's your chemistry, and we'll just translate it as sugar plus water gives you carbon dioxide plus ethanol. And so in making bread, we use mostly the carbon dioxide, and the ethanol evaporates. In making wine and other alcoholic drinks, we mainly rely on the ethanol, and sometimes we save the carbon dioxide for champagne and things like that. And so, so we know that the world's oldest profession is baking. And so we know that the yeast Saccharomyces cerevisiae has been important in human history. And this is actually an old bakery on the top of Masada in Israel. But more importantly, particularly for California, the same fungus, but different strains are used to make wine and champagne and beer and other alcoholic beverages. So here's some red table wine, which is the most famous kind. And so ethyl alcohol and carbon dioxide. Okay, and you can make the same thing for vehicle use. And I'm not sure I approve of using food to make fuel for cars. So that's a debate for another time, I guess. But there are lots of people working on fermenting other kinds of things, waste products to make ethanol and other kinds of fuels. So let's see how that works. So I took this picture on the beach in Santa Cruz, and I think it's a very Santa Cruz picture. So people sitting on the beach in their hoodies and drinking, whoops. See if I can zoom in on that. Can you read it? Cheap white wine. So that's the most Santa Cruz thing I could think of. Of course, many cheeses come from are fermented with fungi as well. Since I tell my students in Wisconsin, they're really excited by cheese. And so, you know that the milk solids are dropped out by bacterial enzymes or calf enzymes. And then you form the cheese and then age it. Other kind of cheeses have fungi added to them to ripen them further. So, for example, blue cheese comes from Penicillium roquefortii. The legend is that a little farmer, a little shepherd boy, was tending his sheep in France, and he left his sandwich in the cave, his cheese sandwich in the cave, and forgot about it, and came back a couple of weeks later, and he ate it anyway, and it was delicious. And so the walls of that cave are still covered with Penicillium roquefortii, and it's only allowed to be called Roquefort cheese if it comes from that region of France, from that cave. And then on Camembert and Brie, the outside is a different Penicillium Camembertii. And you'll notice these are always made in small wheels because they're the enzymes, the exoenzymes that are secreted into the cheese to digest it only can go so far in the cheese. And so that's about the limit, the size of one of those little Brie wheels that they can reach. So probably you like chocolate. I'm not a big fan, but that's okay. And in order to have chocolate, you need fungi. And so, for example, the cacao trees are mycorrhizal with members of the Glamoromycota. Here, this is a Colospora scribiculata. It's a little tiny fruiting bud, is a millimeter or two in size. And then once you've collected the beans, you have to ferment them using Candida krusei and Geotrichum. And Candida krusei is a yeast, obviously, and Geotrichum is this yeast-like thing that kind of breaks up into these little squares and then does the fermentation. And so without fungi, there's no chocolate to eat. Soy sauce is also important. And in order to make real soy sauce, It takes a couple of years. You first ferment it with Aspergillus oryzae and a yeast called Zygosaccharomyces. And then later stages use the Pediococcus halophilus, a bacterium that's salt tolerant or like salt. And so that's where you get the really rich flavor of the soy sauce. There are cheap imitations where they just add a single enzyme and 20 minutes later they have soy sauce. And that is not good. That's just salt and water and some coloring. So look for the fermented stuff. You probably you can't have a happy day without Coke. Happy any day without having Coke or Pepsi or something like that, according to the TV commercials. But you probably know that there's citric acid in here. And so you probably think they have take lemons and limes and mush them together and they extract. That's not how it happens. You take a large vat about the size of whatever room you're in, and you add corn sugar to it, and you add the fungus Aspergillus niger to it, pictured right here. And you swirl that around for a while and give it oxygen. And then you drain the waste products off the bottom, and those waste products are citric acid. And so you should change the slogan to "Things go better with Aspergillus," which none of my students get. And they don't get this one either, "The Joy of Fungi" from Pepsi. I changed the logo too. I waited for a cease and desist letter from them for years and years, and I haven't gotten it yet, so I'm really disappointed. This is tempeh and a nice sandwich. And tempeh is soybeans that are fermented with a Rhizopus species. And that anneals all of the tempeh together, soybeans together, and you can make a little patty out of it and little crumbles of things. So I like it a lot. I think you have to brown it. If you don't like it and you haven't had it browned, I think that's the important thing in it. Okay? And sometimes you can accidentally make fake tempeh in your house, like I did here. So this is probably Rhizopus growing on some kind of casserole that I can't remember what it is, but it had a lid on it. And there's probably 10 to the 9th spores of Rhizopus in here. And so here's a closer view of those. They're sometimes called pin molds because they look like the head of a pin and then stuck in the whatever the substrate is. And actually you can get carotenoid pigments from this. And so before they're mature, they're this carotenoid color. And as they mature, the black color overwhelms that. And so some carotenoid pigments come from this. So at Christmas, you can give the gift of gas, according to this gas station. And if you eat a lot of beans, you might get that gas instead of eating the fungi you're supposed to. And there's an enzyme in beano that reduces the flatulent ability of the beans. And if you like stonewashed jeans, use a trichoderma. There's trichoderma down there. And it partially digests the cotton of the jeans. So you take a giant vat the size of your room you're in, and you throw the jeans in, and you throw in the trichoderma, and you spin that around, and then you take them out at some time. So there are no little old ladies with babushkas that go out to the rocks on the stream and rub on the rocks. That's not how it happens. So these should be called fungally digested jeans and not stonewashed jeans. It's all marketing. Of course, there are lots of indirect benefits of fungi to us. Mycorrhizae are the important ones. Without mycorrhizae, there would almost certainly be no plants on the earth, on land. And thus we wouldn't be here either. And so, of course, myco is fungus and rhiza is root. And more than 90% of plants in nature have mycorrhizae, and it's probably higher than that. There are other fungi associated with the roots as well. Besides mycorrhizae, there are things called dark septate endophytes and other kinds of fungi that probably play a similar role. Okay, and so the mycorrhizae are generally found at the root tips. And then the mycelium extends into the soil and scavenges for minerals and water. while receiving sugars from the tree. And so this is usually portrayed as a symbiosis. Both of those they're Disney form. They're both happy and they're feeding each other and they're all good friends. And that's really not how it is. These are enemies pointing a gun at one another. Give me the sugar or else you don't get anything. Give me the minerals or else you don't get anything. And so it's really a, kind of a fight. And if one of the partners doesn't do its job, the other one eats it. So it's not, the world is not like Disney. The world is not happy and things jumping around. So the underground is really complicated. So I've been studying mycology since 1978. And I think just in the last few years, I have it figured out in my mind what goes on underground with all the things that are happening in there. You have mycorrhizae, you have other fungi, you have insects, you have bacteria that are eating the leeks from the roots. There's little animals, and you have beetles eating them, and the beetles have bacteria and fungi inside of them. It's crazy. And so I have this whole thing in my head, and I haven't figured out how to express it yet. And so I'm probably going to start working with one of my colleagues at La Crosse, who's an artist as well as an insect person. And I think I need for him to help me make a 3D model of it. And so maybe I'll do that before I retire, or maybe I won't. Depends on how ambitious I get. But I think it's way more complicated than we give the credit for. We see these things sitting above ground. You can actually think of the tree as the photosynthetic appendage of the fungus. So here's some mycorrhizal fungi, and we'll try and name them again. So this left.
That's cap.
This is Amanita bisporigera, so it's a Midwestern thing. And East Coast. And then
Scleroderma.
Scleroderma citrinum.
Yes. And then here's the two chanterelles we saw in the other one.
Right.
And these.
Lactarius indigo or no?
Lactarius indigo. And the orange one is probably Lactarius thyinos. It doesn't change in color. The milk doesn't change. That's hard to tell. This one.
Truffle.
Truffles, yep. So this is from Oregon, so I'm not sure whether that's which species. It might be probably tuberculosa or tuber oregonense. This one.
Hypnellum.
Hypnellum, yep, Hypnellum ceruleum.
Wow.
This one. You better recognize this one. You get kicked out of the club.
Or else.
Where else? Yeah. And that's a celandine poppy underneath it. I like this picture. And this one you should know also.
Mycology.
Right. Okay, very good. Okay, so many other fungi are saprophytes or saprobes. They're recyclers in nature. And so here we have Captain Recycling. And we'll just concentrate mostly on wood here. Fungi are really the only good things that can decay wood. There are some bacteria that do, and you can argue about termites, but it's actually not the termites that decay the wood. It's the bacteria in their guts that decay the wood. And so they break down everything into, the carbon, so that can be used by other organisms. And so it's mostly carbon and nitrogen, phosphorus, potassium, calcium, and other things that get broken down. Okay, I'd like to show some mushrooms in art because art is an important thing in our lives, makes us happier. And so here's a few kinds of things where mushrooms have been used in art. This is a Uniderma applanatum, and this is actually a flaw in the fruiting body where the fungus grew through a stick, and the artist made a stick out of it. So I really like this one. Here's some of Maria Hurricane stuff. She's from the East Coast. There's some really nice stuff.
Oh, it's here comes with an E.
And there's in Europe, these are from Germany. These are ornaments for the Christmas tree that I bought at the Christkindlmarkt in Nuremberg. And so here's a hallucinogenic mushroom on the top of these. It's supposed to bring good luck to you. I saw it in the store of beauty shop, in the front window of beauty shops and places like that. And here on top of this lottery kiosk. And so here's the usual good luck stuff, the 4-leaf clover, but here's also the little Amanita muscaria that's going to give you good luck. And of course, there's many forms of it. I've shown you some of the colors that you can see here. Here's a drawing of me by Maria Lee, my former student. She drew this from Coprinus ink. So, and here's another one she made. The blue is not from Coprinus, but from another one. And so this was, she made this into a t-shirt for the 5th anniversary of my heart transplant, and set up a store for people to buy them. And so there's a bunch of people that are wearing my shirts. This is some Foamy cementarius that's made into doilies. One of these is from Phyllis's house, and I don't remember which one. It might be this one. It could be both. And then handbags are made, and this is by pounding down a polypore until it makes this kind of mushroom felt. And there are companies now trying to exploit this. These were mostly made in Transylvania by just a few people, and now there's some people exploring them using this commercially. There's Oman from Nigeria with his hat. And then other fungi are used, as some of you may know Todd Elliott, who's now in graduate school as a PhD school, with his Trametes versicolor hat. And here's, I actually submitted this in a photo contest and won, probably because the judge was from Hawaii, and this looks a lot like lava. And so this is Phlebia coccineovulva. It's really pretty crust. And actually, you can kind of see the shine on it, the bloom on it. Those are cystidia. They're really big. So it's cool microscopically as well. And of course, this was the sign. Sometimes the people at a venue where you're having a foray don't quite understand, and they said that from 9 to 10:30 you're going to be dying from mushrooms, when they actually meant dying with mushrooms. So close. They probably thought, what the hell's going on at this place? They're going to kill people. But in any case, these are from Susan Hopkins. Some of you may be fortunate to have the little doll that she crocheted or knitted, I think. Knitted, thank you. I was going to ask you. And so here are some of the fungi, and she's labeled what each of the colors comes from. So I like this a lot. Some silks that were dyed at a foray I took pictures of. These might be some of Alyssa Allen's, but I can't remember who did these. And then these are, some of the various colors using different kind of mordants to anneal the dye to the wool. And so really pretty colors that you can get from that. And so after my heart transplant, my dear friends in Seattle thought that I shouldn't be just carrying this around like this. And so they made me a heart cozy. And so this is a heart cozy felted, made with wool that's dyed with mushrooms. And so my heart stays inside of that in a Tupperware kind of container. And then the outside has these different motifs of mushrooms and such. So there's the date of my transplant. And you can see the various kinds of things that were made. So this is one of my prized possessions. All right, so we had some kind of, well, I guess that last one's extraordinary, but mostly we're ordinary, everyday fungal superheroes. Let's look at some extraordinary ones. Okay, so there's something called the law of microbial infallibility that says for every chemical that's out there, there's a microbe that can degrade it. And so this is mostly true, but there are some chemicals, man-made chemicals, human-made chemicals that are not yet degradable by fungi. And so I like this picture too. This is why I'm not dead, I tell people. So, and so I'm going to skip to, I'm going to skip to the bioremediation, and I'm going to do it this way. Okay, so one of the fungi that are used in this are white rot fungi, and most of you probably know about white rot and brown rot fungi. Wood is composed of cellulose and lignin, one of which is white and one which is brown. And the brown rot fungi digest cellulose and leave the lignin behind. And in the simplest form, white rot fungi digest lignin and leave the cellulose behind. Okay, so that remains stringy, but the brown color is gone. And then because the primary wall is gone in brown rot, it's really crumbly and powdery eventually. And so in biopulping, it's been proposed, and it works in the lab, to get out all of the brown in the wood to make paper and do it in a sustainable, easy way that's not polluting. And so this is the fungus that is mostly been used for that. This is Phanerogete chrysosphorium. That's the fruiting body of it. So it's a little crust fungus. It's only been isolated 25 or so times in nature, and always from compost piles of wood. So strange fungus. And so what's being envisioned is that you have this clean power plant where you put in the fungus on the long conveyor belt, put it into these rollers that twist around with the fungus, and then take the pulp out after a couple of months. And so that's sort of a pie in the sky kind of thing. It works really well in the Petri dish and in small piles. But when people tried to scale it up to an industrial size, or even a pile, that's 6 feet tall, it doesn't work, because the pile becomes too anaerobic in the center without oxygen, and this fungus can't grow. So it does, and it's too hot. So this fungus is mostly chosen because its optimal temperature is 30 degrees centigrade, which is about 80, 85 degrees Fahrenheit. And so it can deal with some of the heat, but not all of it. There's maybe more hope for fungi with bioremediation, particularly with chlorinated methylated aromatic compounds. They look a lot like lignin. And so the fungi that can degrade lignin can also break these down. And so here we have the PCPs and benzoate pyrene and other kinds of things that can be broken down. So I had a grad student who was really interested in this sort of bioremediation, but we wanted to look at plastics. And you've seen studies with using Pleurotus for oil barriers. But here's Adam Gussie, who was really interested in saving the world, like all good grad students should be. And he was a good chemist also. So we we tried to degrade phenolic resin polymers, a plastic, by white rot fungi. And so phenolic resin is a very common first plastic. Something called Bakelite used to be really common. The bowling balls are made of phenolic resin. Bowling balls are a single chemical, or a single molecule, I mean, with one chemical in it. Okay? It's used a lot now for plywood, gluing the pieces together, or particle board, and used in brake linings. So there's still 2.2 metric tons of this made every year in the United States. And so we wanted to find a way to degrade this. And it's made with phenol and formaldehyde, both of which are toxic. Okay? And so here's the phenolic resin. And we wanted to see if we could degrade it using fungi. We'll look at that again because it took me 3 hours to make that. One more time. Okay, so this was our first experiment to show this. We had a small grant from the State Recycling Commission to do some experiments. So this is Phanerachida Cyclosporine growing alone on a plate. And we made our own plastic so we can make little chips of it. And you can see that in the control, that's just the resin in the media. There's nothing leaking out of it. So it's a solid piece of plastic. And when you put the two together, you get this pink color. And the pink color is the breakdown product of phenol and formaldehyde, which we showed by other means. We showed it in gas chromatography and mass spectrometry, which I'm not going to go into here. And we also looked at it microscopically and could see that these were degraded. And so this was a really interesting paper that we published. And it's on my webpage if you want to link to it and see all of the evidence. Okay, so there are some extraordinary roles of fungi in everyday lives and some really extraordinary ones, especially ones that have a lot of potential for this use that haven't been totally explored yet. And certainly there are many more fungi to be discovered that will do things that you'll be really surprised at. And so you can visit my webpage, and I thank you very much. I'm happy to answer any questions.
If you have questions, be sure to unmute your microphone.
You're probably going to have to get me out of this speaker view because I can't do it on I'm missing the top 3/4 of an inch of my screen. Just get me out of it.
Oh, okay, hang on. Oh, here we go. I'll just share my screen quickly, and that'll get rid of your share screen. There we go. Share. And now I will stop my share. Okay.
Tom, I have a question.
Yes.
I plant a lot in pots. Would it be helpful to put the blocks from Far West fungi in there to create some mycelium or something, or not?
What kind of things are you planting?
I've got a rosebud tree, flowers, everything. Vegetables, tomatoes, everything.
So those are mostly forming what we call AMF or endomycorrhizae, not the kinds of fungi that you would be able to get in a block. And so they're microscopic fungi that are in the roots and attached to them. And so there are commercially available mixes, but we've had really mixed results on whether they actually work. In a study one of my students did, there was no effect of adding the mycorrhizal inoculum to 4 different kinds of plants.
Okay. I just feel bad that I'm not feeding them properly.
Well, it depends on where your soil is coming from.
Yeah. Costco.
There's always the danger if you add other soil that it's going to, it's going to have other fungi and bacteria that are going to kill it.
Ooh.
And so, they tend to use sterilized soil in places like that in greenhouses. And if you're giving it extraneous minerals, that actually would kill the fungi that would be on the roots. Because again, I talked about this fight. If the plant doesn't need it, it doesn't let the fungus in.
Huh.
And so this is one of the big problems in agriculture. We're trying to add these fungi to the soil. But if you fertilize it, then you lose the fungi. So it's finding that proper balance between those two things that's important.
Okay, thanks.
So, Tom, you mentioned your T-shirt. Are they still available?
No, I think they're all gone.
Really?
Unless somebody's going to make one for my 15th anniversary. I don't think so, though.
Well, I do need one. So
I'm honored.
Any day when I'm having a bad day, that's a T-shirt that I can put on and look at and say, "Hey, here's somebody who's been through more than I have." All right. Well,
that's a very nice thing to say. Thank you.
Well, and I'm sure you will get to 15, and if so, and I hope you will.
We only got 3 days. I hope so.
I hope you will encourage somebody to do that T-shirt, and the images that you showed earlier are really quite compelling. So I'll be happy to take a case here and sell them on the West Coast, and I can be enthusiastic about that.
Well, thank you, Richard.
Tom, this is Richard Romer. I recently saw an article, just today, I recently saw an article in Atlantic talking about a fungus that is infecting the cicada that is emerging. And one of the things that they talked about was the fact that it was excreting LSD. And they think that may be the way that it was controlling the behavior of these male cicadas to be hyperactive and hypersexual, even though it doesn't help them, because the rear third of their body is just this fungal mass, and it's their way of spreading the spores around. And it was a really interesting thing, because LSD is, being used to control things. A slight different take on the cordyceps, type of fungi. But this one, I thought it was a rather unique kind of thing that was just discovered. And I don't know if you've seen that article, but
it was discovered 3 or 4 years ago in some of the annual cicadas.
Right.
And so we're expecting, on the East Coast and Midwest, lots of cicadas this year. I'm far enough north that we don't get them. But they call that the flying salt shaker of death.
Right.
So it's got all these spores on it, spreading the spores. They exhibit female behavior, so encouraging males to mate with them. And they spread them to other ones as they're mating with the other ones. And so they drop down into the ground, they grow, and then sit in there for 17 years infected, and then come out and spread their spores again. It's crazy.
Yeah. Wow.
Sure. I think there's also amphetamine produced that keeps them going like an Energizer bunny.
Yeah, that's right. Amphetamines were also part of that mix.
Yeah, there are a lot of fungi that affect the behavior of insects. Cordyceps, we have the ant cordyceps, the zombie ants, and things like that are all well known. I'm not sure which Roz, do you know which, where Massospora goes phylogenetically?
Out there.
Are you still there? Maybe she's not there anymore.
Okay.
Anybody else know where it goes? Elsa, do you know? I don't know where it goes. I think it's an ASCO.
Yeah.
I'm not sure.
Massospora? Okay, we can Google that.
Massospora. Other questions?
Yeah, I had one regarding.
Entomophteralis. Oh.
Oh, yeah, okay.
Entomophteralis.
What's an Entomophteralis? Okay.
That's
What's that?
Wikipedia. I don't know whether it's still true. So
Oh, Wikipedia is always right.
yeah.
So a Nicotizygo or Zygomycotina. Oh, go ahead with your question.
Yeah, I was going to ask you a question about the sort of competition or love-hate relationship between the mycorrhizal fungi and their hosts. You already touched on what the plant will do if it doesn't need the fungus. Now, say the plant is having a hard time and isn't providing any sugar for the fungus. Does the fungus just basically go and attack the plant, or?
Sometimes it does.
Okay.
Sometimes it just stops. If it doesn't, if the plant isn't giving it any food, it doesn't have any choice but to hold back things or die.
Oh, so
It
just
becomes
hold
weakened
back
as
on
well.
moisture. And...
Yeah.
Yeah, it's well known. Okay.
Okay.
It's a really quid pro quo relationship.
Yeah.
I've got kind of a follow-up question on that. It's kind of an oddball question, but how do you feel about there being potential fungi on other planets like Mars? I saw this kind of preposterous article about potential findings of some strange growths, probably just crystals and things like that. But how do you feel like fungi would persist in an environment that's dying and decaying, where it's like totally devoid of planet or plant life?
So I read that paper pretty critically and zoomed in on all the pictures, put them at high res and zoomed in on them. And I don't find anything believable that they say in there. I'm not saying that they're...
That was my conclusion as well. But I did think it was an interesting thought.
If you look at the authors of the paper, none of them are mycologists. They're all physicists, and they're not... I think there's one astrobiologist in there who probably may or may not know much about fungi. So I've actually gotten an email from them asking me to collaborate, and I'm sort of hesitant to do that. But I don't want the bad information to get out there, so I may do it. I've just gotten it like 2 days ago.
I mean, it was all pretty recent.
But have published quite a few papers on it.
Yeah.
Yeah.
It was a preprint. I don't even know that it actually got.
No, there are several others. The same group of people that are just. Yeah. Anyway. Okay.
I think that if there are fungi on Mars, they would be melanized. So they would have melanin in their walls because they would have to deal with the ionizing radiation would be coming in pretty hard at them. And so I can't imagine anything being there without having melanin in them or some kind of pigment that it's an absorber, protect them from the UV and other ionizing radiation. I learned a new word. I did learn a new word from that paper, and the word is pareidolia, which means seeing things that you really want to see, like seeing angels in the clouds or seeing the Virgin Mary in a piece of toast.
Yep.
That's pareidolia. It's a really good word.
I'll have to look that one up. Well, thank you.
Pareidolia. Other questions?
Well, let me be the first to thank you, Tom. That was great talk, as always.
Good, thank you.
Really enjoyed it.
I'll have to do it in person or do a different talk in person someday.
Yes. Once they-
Someday soon,
Soon.
we hope.
Here I
You
am.
think we're going to be cleared by January?
I think we're going to be cleared by September.
Think so? Good.
We'll see.
I'm optimistic.
I had one minor question was,
Okay.
are they doing anything like we breed plants and we breed trees? Is anybody doing anything with fungi as a breeding sort of?
Oh yeah, that's been going on for millennia. You know, you did selective breeding. You pick out the fungus that you like that has the characteristics you want, and you can either breed it with others to get better characters, or you can clone it. So people have been cloning fungi for thousands of years. We've been cloning plants since the 1950s. So there's really nothing wrong with cloning in those groups. And, cloning animals is a more recent thing. I don't think that's ever going to really catch on, but I don't know how I feel about that yet.
Thank you.
Yep. Any other questions? You can ask me about anything. Doesn't have to deal with what this is. This could be your,
So who
ask a mycologist, stump the mycologist question.
How about something else? Who owns the big six packs now? Used to be Heidelman's, wasn't it?
It's not Heilmann's now. It's Pabst owned it for a while, and they sold it off to a consortium of employees. So the employees own it now.
Oh, are they making decent beer?
They're using the original old style recipe,
Oh, okay.
but they're not allowed to call it that because of copyright things.
They had two. They had their regular beer and their export.
Yep, special export.
Yeah, special export.
That means it went all the way to Minnesota.
Since I went to the University of Wisconsin, I drank a lot of Heidelman's.
I've got one more question that I'll toss out. You were talking about breaking down like the phenolic resins. What do you think are some promising molecules that need to be addressed that fungi have the capability of tackling in the short term?
Anything that has the structure of lignin, any of the bonds in it. Lignin is actually really complex compared to even the phenolic resin. It has lots and lots of different kinds of bonds in it, whereas the phenolic resin just has one of those different kinds. And so, anything that contains that, there's some prospect for mineral uptake by fungi. But of course, you can't remediate metals because they can't be turned to anything. They're just metals. So, there are a lot of fungi that can pick up the metals, but then what do you do with them? So I had a student who worked on some contaminated soil with arsenic in it. And she found fungi growing in there that could grow at 10,000 times the EPA allowable level. And so, there are some things, if you could find a way to, do something with those minerals, people are trying to do this in places, picking up arsenic and lead is one thing, but picking up uranium and cesium is another thing. What do you do with that? And so, there's a lot of things, people are tempting with that. People are looking at other kinds of plastics and fungi. And there's some reports of a mold called Pestalozziopsis that's degrading. I don't remember what kind of plastic now, but I'm so mad at them because they completely ignored my paper and their paper. So it's the first time a plastic has ever been remediated, and it wasn't.
Oh. Well, very interesting. Have to look a little more into that. But
yeah, there's a whole lot of stuff that people are trying. There was a lot of experiments in the 80s and into the 90s. But people gave up on it kind of when they found out it didn't work very much on an industrial level. So scaling it up requires, the mycologists have to work with the engineers, have to work with everybody else, the chemists, to be able to figure out how to do this.
Seems like a fairly consistent problem in bringing a lot of these mycological solutions to scale. So.
Yeah.
When the mushroom takes up a metal, does it concentrate it in the hyphae or does it concentrate it in the spore body? When she was talking about the arsenic, for example.
We don't know how this particular one works, but there are a couple of different ways that they can tolerate the arsenic. And one of them is to pump it back out so it never gets in. So there are pumps in some of them get rid of it. Some of them move it into vacuoles, so spaces in the cell where they sequester it away from the machinery of the cell. And there's another way that's similar to that, that's slightly different. But they don't actually use it. They have to sequester it away or get rid of it.
So they would never be edible.
They would not be edible.
Okay.
One of the ways if you're forming a fruiting body is to dump all your metals up into the fruiting body, because the fruiting body is not only for dispersing spores, but it's also the fungal toilet. Right? So if you're eating through the soil, right, or eating through something, where are you going to put your waste products? They make the same waste products we do. They can't dump ahead of them because that's where they're going to eat next. So they dump it back into the mycelium. And when the time comes, they dump it into the fruiting body. So there are many fungi known to accumulate arsenic and cesium and such. Some of the mycorrhizal stuff, like I know that Lacaria does for sure. And it's been well documented, but there are lots of others too. Actually, the first way we knew that there was a nuclear accident at Chernobyl was the radioactivity that showed up in the lichens in Scandinavia because the reindeer were eating them. And it was showing up in the reindeer meat because they didn't tell anybody.
But now we have fungi growing inside the reactors, right?
We do.
So
those are melanized. So the melanin is there again. There's a paper that says
Want me to
that
turn
the
off?
fungi are using melanin to kind of photosynthesize, so radiosynthesis. My student, who's maybe the smartest person I've known, disproved it. So it's not radiosynthesis in the same way that photosynthesis is photosynthesis. But there are definitely fungi that are in there and growing. What they're doing, I don't know. Justin, what are you playing? What song are you playing on the guitar?
Nothing in particular.
I've never had anyone play a guitar during my talk.
Well, you've had
I think it's great.
knitting and crocheting and guitar playing and everything now.
I once gave a lecture at a mountaineer club near Seattle, and it was on a it was on one of those it was on a karaoke machine, and I looked up in the middle of my talk, and there were two guys in the front row playing chess. My friend said I should have yelled at them, but I thought it was hilarious.
It might be their method of absorption.
It was fine with me. I didn't care if they were interested. I can't, so long being a teacher, I've had everything happen in class.
Good point.
Except for somebody having a baby.
Hopefully not.
I did have somebody have a seizure once. That was kind of cool. Fortunately, he was sitting next to a nurse. So
worked out. I mean, better to not have a seizure, I suppose.
Yeah. Any other questions? You can ask me anything. You can ask me about my transplant if you want. I tell all the story.
Well, Tom, when you get to California, we need to find time to walk in the woods and then do a beer crawl through here, because there's a lot more craft beer here than the last time you were here.
Yeah.
And there's some awfully good work. So let's find time to do that the
Good.
next time you're here.
Yeah. I don't drink very much anymore, but I'm happy to go places.
Well, so just we can do little sips then.
Yeah.
All right. Glad to have you here.
Thanks, Richard. Glad to see you.
Take care.
Anybody else have a question, or are you ready to wrap it up?
Well, I have a sort of a side question, since someone was asking, I noticed in the chat about where the recording of your talk will be, and it's currently on our YouTube channel. Can we leave it up on YouTube indefinitely?
Sure.
Oh, okay, great. Hope that answered your question, Josefa. Yep.
Well, again, thank you very much. That was most interesting and most entertaining.
Good, thank you. I'm glad to be here.
Always good to see you, Tom.
Wish I was there, though.
Yeah. Oh, we
Wish you were here too.
We do too.
Yeah.
So,
Thank you very much. It was a great talk. Really appreciated
Hey,
it.
thank you.
Yep.
Thank you,
See you
Tom.
again.
Nancy, I get to see your face.
Good luck with that heart.
Thank you.
all right.
Thanks again.
Good night, all.
Great. Night.
Yeah, Phil. Yeah.
Take care. Stay safe. Stay healthy.
Yeah, did you get antibody levels for your, I'm assuming you got the COVID vaccines, and because you're on rejection medications, you might not have achieved the same level.
Right. Yeah, I have appointments next week with all my doctors for my anniversary annual checkup, so I have to check with them about that. I'm on a really minimal dose of anti-rejection drugs, so I'm hoping they'll do an antibody test and let me see what's going on.
Yeah, you may only be able to get a qualitative and not a quantitative. If you can get a quantitative, it might be nice to follow it either qualitatively or quantitatively serially to see if the vaccine seemed to have worked and to see if and when you should get a booster. In the meantime, you probably have to continue to mask and socially distance because it might not have worked as well as it should have.
Right. Thank you. I appreciate your concern.
Yeah, we want to.
They said that I went and looked at the original paper in JAMA, and their details are not very good in there. Like, I don't know what any of the people were taking on their test, that they tested. They tested 600 and some people, and I don't know what drugs they were on or what stages they were in or anything like that. So I think I just need to get tested for that.
Well, that is also why people have to get vaccinated and stay masked if they haven't been vaccinated, and basically just get this virus out of existence in our society.
We have a really good history of doing that with viruses.
Yeah. Oh, well.
Yeah, that would be good.
Yeah, I was thinking, I was pretty optimistic until that paper came out.
Well, maybe you'll have positive titers. I wouldn't worry about it. Just follow it serially.
Yeah.
Maybe check every month or two. Make sure you still have them.
Yeah, I have to request that test next week.
Yeah. Okay.
Thank you. I appreciate it.
Sure. I'm looking forward to watching your talk again, because that was a lot of great information. And yeah, and I have a couple of friends that live locally that I noticed weren't watching this today, and they will be so happy to be able to watch that when they, when they have time. So I'm looking forward to passing that on. Thank you.
I should have plugged my TED Talk too about my transplant. So you can go see that. It's on the YouTube.
Okay.
All right, well, I
Sounds
look forward to
fascinating.
seeing you in September.
Yeah.
Roz, how are you doing?
Good.
Are you in New Hampshire or where?
I live in New Hampshire, northern New Hampshire,
Okay,
in the White Mountains.
nice.
Mm.
You're still skiing? Or is it too late?
Yeah. I skied this winter.
Yeah.
I had my knee replaced in
Oh.
last July, and I kind of had trouble with my legs since, but I didn't. I could have trouble walking, but I could ski fine.
That's interesting.
The problem was that by changing the knee, it misaligned the leg,
Oh,
and so my hips started hurting.
I could see that.
But it's okay. It'll be okay.
Good.
So I found a hebuloma the other day, and that was just really unusual.
It's really early.
It turns out there's one that does occur in the spring
Okay.
or June, so it's a little bit early.
Usually when I don't know what it is and it's bark sport, it's a hemolymph.
What did you say?
Usually when I see a dark sport thing and I don't know what it is, it turns out to be a hebuloma.
Oh, I hardly ever find them.
Yeah, we don't have too many around here.
But it was funny because I knew that the smell was familiar, but I couldn't figure out what it was. And then I finally decided it was radish, but I guess it was horseradish. Smells are strange.
Yeah. You had to have someone suggest the smell to you.
Mm-hmm.
That's a type of pareidolia.
You practicing your new word.
Mm-hmm.
So you put the pictures of that guy before. Always had a weird.
All right. Well, thank you for having me.
Thank you.
I'll see you again another time.
Soon. We hope.
So cool.
See you in September, perhaps. Okay. Bye-bye.
Bye.
Okay. Bye all.
Good night.
All right.
All right. Good to see you, Tom.
See you too.
Bye, everybody.
Okay.
Peter.
Bye,
Good to see
Peter.
you.
Yep. I'll see you in the fall, or probably maybe we'll have a meeting this summer.
I'm sure we will.
On Zoom. I was going to say, did you get together with
Bill?
With Bill? Yeah.
Yeah, I did.
Yeah.
Bill and Dave, somebody also came. We had we just had a couple beers at that Roma Squirrel. It was fun.
Yeah, I'll have to come. I was thinking of going down there, but something came up this morning, so I couldn't make it. But
We can always do another one, Dan.
yeah.
Cool,
Yeah.
man. All right, stay in touch.
Take care.
Thanks, guys.
Okay. I better end this thing.
I was gonna say the YouTube stream probably ended a while ago.
Yeah. I should have ended it a while ago. I think my recording may have ended early too. Oh well.